Morning, everyone. My name is Menek Shekaya. I am the cluster manager for Construction Cluster Ireland. As you know, thanks for joining us today for the second session of the Meet the Member series. This series aims to foster collaboration among members by getting to know each other's expertise and service areas. So that aims to help you identify the right partners for your business needs and your projects. Today, we are joined by Harcourt Technologies Ltd for this session, and Justin Kinsella will present this morning and take your questions at the end. Before we start, I would like to introduce Justin to you briefly. Uh, Justin studied architecture at Dundee University in Scotland, where his chosen specialism included sustainable design. After his studies, he started working in offices in New York and Dublin and later established Harcourt Architects in 2003, where he completed and led both design and development teams in a wide range of sectors, including hospitality, offices, and large one-off private houses and master planned communities, with projects predominantly located in the US, the UK, and Ireland. Justin has always been an advocate for sustainable design and construction, and his interest in socially and ecologically conscious development and innovative construction technologies naturally led to his interest in the 3D construction printing sector. Harcourt Technologies Ltd was established in 2020 with the view of harnessing 3D construction printing to produce sustainable housing systems that address affordable housing supply and the adverse environmental impact of traditional construction. Without further ado, I'm handing the microphone to Justin now. Justin, the stage is yours. I'll mute myself.
No problem. Thanks very much, Maneska. Appreciate that. Justin Kinsella, come from an architectural background. We have a company called Harcourt Architects, who was primarily interested in, we're actually tasked with looking at social housing, affordable social housing in North UK about 2 years ago. And we started looking at modern methods of construction. And basically our objective was to just try and find ways of increasing affordability, seeing what methods were out there. We analysed various methodologies, and we became exposed to 3D concrete printing during the course of that research. And as a consequence, we started doing our analysis, and here we are. So we now have a sister company to our ongoing architectural practice, which is Harcourt Technologies, or HTL.Tech, as we branded it. And we're engaged with 3D construction printing in Ireland and the UK. And we're working with a company from Copenhagen called Cobod, who are the largest commercial manufacturers of 3D construction printing equipment in the world. I'll give you a quick run through on just an overview presentation for anybody that's not familiar with 3D construction printing, because it's still quite a novel technology. And I'll also share some videos. We have an R&D facility in Drogheda, County Louth, where we have a team that's working on preparing for social housing development in the North UK. And it'll just give you an overview of how the technology works and the type of things we're up to at the moment. And I'll also just give you a quick overview of a project that is current at the moment, just to give you an understanding how this technology works when combined with other methods of construction, other components that we need to actually deliver a finished product, housing units. So I'll just start with the overview presentation, and I'll run through quite quickly, just do about 30 minutes, and then have about 10 minutes at the end for any questions. So that's generally the overview. 3D construction printing, this company started in probably 2017, I think, Cobod, the one we're working with, and they make the equipment. And they're also in partnership with a company called Cemex, I think the third largest concrete producing company in the world. And together they have come up with a methodology of allowing these printers to use just regular concrete, regular aggregates from anywhere in the world, with the addition of some additives which allow the concrete to be printed. This is an image of us in our R&D facility. So we have a full team of architects, engineers, mechanical engineers, construction technologists, and that's a picture of our client for our pilot scheme in Accrington. We are we're engaged with the equipment, so we also supply the equipment in Ireland and the UK. We're also engaged in developing new materials that are printable, where we're kind of focusing on reducing the cement content because it's the largest carbon emitting embodied material in the concrete. And we're also engaged in coming up with the best way of pairing this technology with the other intrinsic components that already exist in the construction environment, and trying to capitalize on how we transfer our digital models as architects into the actual produced building on site, which is something that 3D construction printing does inherently. A couple of photos of us. We set this machine up in Drogheda in February of this year. Came over from Copenhagen. We had a team that installed it. There were the Danish engineers. They had actually come from a site in New York, where they're working with General Electric using the same technology. I'll give you a little overview on that in a moment. This is an overview of our central team. That's myself. We have Dr. Martin van den Heever. He is an engineer, but also he is a PhD in 3D construction printing and the associated materials. Martin can't be on the call today. They're actually running test prints at the facility in Drogheda. We have Terry Round, who comes from a traditional 3D printing background, brought the technology into Ireland about 30 years ago, the first mover, and also has a sister company, which is now one of the largest distributors of traditional 3D printing. But Terry introduced the technology to us. Initially, we thought it was something that's going to happen in the distant future, and we started realizing that this was ongoing, particularly in Germany and the US, and it had successfully been brought through the regulatory compliance in Germany, which led us to believe, or to gave us the, I suppose, the conviction to say, well, if they can do it in Germany, we can achieve compliance in the UK and Ireland. Paul, who's my colleague, who's on the call as well. Paul is an architect and co-director in both Harcourt Architects and Harcourt Technologies. Richard, also an architect, can't be on the call, but Richard would focus on adopting the technology to work within the existing building codes and regulatory system in Ireland and UK. Then a good support team, and we also have an advisory member of the team, Michael Morris, who is involved in probably more frontier projects. He has a practice in New York, and they're engaged in, it might sound quite far out, but in off-world habitations, and he has worked with NASA, but allows us to get a view of the type of technology that's coming down the line. So it's quite an interesting advisory capacity, and we're lucky to have Michael. Just general information about 3D construction printing. As you're probably all aware, this is a McKinsey report from 2017, capacity for automation within construction. It's one of the largest untapped I suppose methodologies within construction. It's still a very conventional industry, but they estimate that 47% of all activities involved in construction can be automated. At the moment, we're all aware of, and these were factors that led us to engage so deeply on this project. We have demographics that give rise to a shortage of skilled labour. It looks like that is not going to get any better. We can see how difficult it is at the moment. Generally, young people don't want to get involved in what would be traditionally bricklaying and the kind of heavy manual work that's traditionally involved in construction. From a delivery point of view, that's impacting output in housing and impacting affordability. And also material inflation is something that we're all aware of as well, where it's very hard to predetermine where a project will arrive at. This technology, we found, allows one to predetermine pretty exactly the amount of material that's required and also the timelines. It's intrinsic in the software and the digital flow of the work from the office to the site, which we've seen as a benefit and something that we will document in our project and quantify. The general, I suppose, positive corollaries of using this equipment, labour, we're finding from projects all around the world and our own projections that the labour ratio on a project will reduce from 70% to 30% using the technology. There's other positive benefits in that there is a reduction in working at height and health and safety issues with lifting. And it's also quite a it's an open it allows more access to I suppose women in construction, even people that aren't fully able can operate this equipment. The technology is that advanced. Speed of construction, we're finding that we can increase output by about 50%. I'll give you the stats on the projects that we're actually working on at the moment, but we're looking to deliver on our first project 6 apartments over 3 floors with completion on the superstructure within 12 days, and that's including a 50% contingency. I'll give you a look at that in a moment. But that has a lot of knock-on effects in relation to the cost of conducting a project, investor returns, and this isn't only achieved by the speed of the print. Printing machines at the moment can give an output of about 30 square meters per hour, but the digital accuracy of the print allows us to be able to pre-order components and to have the surety when those components come onto site, such as cassette flooring, windows, doors, roof, and any infill that's required. We know with certainty that it will fit, and it's not like the conventional situation where the superstructure is completed manually. Then specialist subcontractors have to come in and measure and fabricate and then bring the components. We're eliminating that aspect and trying to push the whole process forward in a much more efficient manner. From a sustainability point of view, due to the accuracy of the placement of the material, we're seeing a reduction in waste on like for like, because just to be clear, the 3D construction printing aspect only replaces the superstructure. You may see things online where they give the impression that the whole house is 3D printed. That's not possible. But our process at the moment is to replace the big bulky element, i.e. the superstructure. And it's really just substituting the cavity wall a traditional concrete block cavity wall with placed concrete in exactly the same locations and using the same construction methodology and position within the regulatory compliance and building code. But by doing that, we're seeing a reduction in waste comparatively of 60% with regards to materials under the upcoming EU legislation to reduce carbon embodiment in construction. Reduction of waste is the #1 methodology to reduce carbon embodiment in construction. This technology inherently does that. Other aspects that contribute to the sustainability is the fact that all the materials can be sourced locally. And this is kind of the genius of CoPod, in that the equipment, it's basically bringing the equipment to site, bringing a factory kind of situation to site, but relying on the local aggregates, the local sand, the local stone, the local cement. So all these things can be sourced directly. There's no reliance on geographical areas, as we see geopolitical situation at the moment, where one might be relying on prefabricated units coming from somewhere that might be under difficulty. Also the cost of transport, that eliminates that situation, and then also the carbon embodiment that's associated. Then we are also engaged with some companies where we are trialing low embodied carbon substitutes for cement. We can eliminate the cement fully. It becomes virtually no carbon embodiment in the actual material. We're not there yet. We're still using traditional concretes, but as I say, the material reduction of 60% is a massive contributor, along with the reduction in the amount of carriage and transport and the associated embodiment. The final thing on sustainability, and something that when we engage with building control in the UK, we're able to deliver a far more consistent output, which allows for the basically very well sealed envelope and a better operating life cycle as a consequence. From an energy perspective, from a cost perspective, with our current project just out of from the get-go, we're looking at doing maybe a 20 to 25% cost reduction on a comparative cost for a superstructure, i.e. a traditional cavity block wall. So the cost that we're seeing, that's including the capital cost of the equipment, is a 25% reduction. Then we will quantify the other reductions with this project to give real empirical and reliable evidence to illustrate the other cost reductions in the speed and the reductions in waste. From a social perspective, we believe this has the capacity to make housing more affordable, increase the output, and negate that current impasse we have, the ability actually to produce the amount of housing that's necessary. Quality and compliance, as we discussed, that's something that building control really enjoys about this technology. It's inherently accurate. The machine can't deviate from the BIM model that we create as architects in the office. When we make a Revit model and we build the project virtually, we know with surety that that Revit model is going to be recreated on site. There are very few other technologies that we're aware of that can achieve this, and that can happen within a matter of probably 15 minutes. We use a plugin into Revit and it'll identify the area being printed and it'll transfer it into a file that the printer will understand, basically G code, which just tells the printer head where to go. Again, that's the sustainable aspects. I've kind of touched on all that stuff. I'll just keep running through here. Checking the time. These are the types of printers that are available. It's a gantry type of system. The one on the left is a R&D printer. That's the one we currently have set up in Drogheda. The one in the centre is for moderate to medium-sized projects. And then the one that we're using for the Accrington project, which we just took delivery of there recently, is called a 584. How you refer to these printers, when I say 584, they're based on modules. So that means there's 5 modules it's on an X, Y, and Z axis. So that means there's 5 modules on the X axis, 8 modules on the Y axis, and then 4 modules on the Z axis. And what that translates into, each module is 2.5 meters long. So it means that we have a printable area roughly 5 times 2.5, 8 times 2.5, and 4 times 2.5. So in real terms, it allows us to print 12 meters in width, roughly 20 meters in length, and then we can get up to about 8.7 meters because we put feet on it in height, which allows us to do a 3-story building. This will be placed over a apartment block, which I'll show you now in a second. This is just general information about the progress around the world. It's in every continent. It's also in Australia now, and we just need to update our presentation, but predominantly most projects happening in Germany, Austria, Belgium, and then in the US. This just gives a kind of snapshot of where the technology is at. It's just from a recent paper published. It's been growing, it's kind of exploded within the last 2 years. This graph illustrates the number of academic papers in red, the number of patents which relate primarily to the printable materials, and then the one in dark blue is in the number of projects which are currently underway. And that, as you can see, it's really gaining pace, and that's a very positive thing because it means a lot of data is now starting to become available, and there's a lot of very clever people working on this, which is pushing the technology forward very quickly. This just shows the market and where it's projected to be by 2027 worldwide. They think it'll increase to quite a substantial figure. It'll be a 30 billion pound market by 2027. This is just an overview of the output in Ireland and the UK and the capacity this equipment has to address that. These are projects around the world. This is Icon based in the US, quite a nice architectural application of the technology. This is, it's been used in the HS2 system, the new rail system linking London to North UK. And they're also introducing graphene, which is a very interesting material and which should really benefit the advancement of the technology, as it allows even less material to be used in more diverse manners and reduces carbon embodiment. This is the project I mentioned before. So before the guys came to Drogheda, they set up a printer for GE in New York. GE are currently using the printer to build the large bases on the wind turbines in remote areas where they traditionally couldn't prefabricate steel bases and get it to these remote places because they were limited by the basically road widths and rail width. So now GE are able to build these very large turbine bases, and their objective is to get up to about 150 meters in height. By doing so, they get away from ground turbulence and increase the efficiency of the turbines by between 20 and 30%, which makes an awful lot of sense over the life cycle of these turbines, but just illustrates the uses. There's any number of uses for this technology. We're focusing on housing, but we're seeing a lot of other uses. These are projects in Germany. It's a single house completed last year, currently inhabited, all fully permitted under German building regulations. And that's it. During the construction process, we're using different detailing. We've made it more efficient. We figured out a way of using the concrete in a structural capacity, thanks to the work of Cemex and Cobod. That is the printer just operating. That's called the corduroy style, where it's just printing additive layers without smoothing. It's one way of doing it. The way we do it, we use smoothing plates just to give a smooth texture, so we can expose the concrete primarily externally, and it's easier to maintain, we believe, and probably a bit more of a palatable aesthetic for a new market. And that building is now currently inhabited, and that's currently the largest multi-family residential 3D printed building in Europe. And our upcoming project will exceed that. We'll have the largest and first in the UK. It'll be the largest in Europe for a period of time, and then somebody else will exceed it. That's a project in Belgium, which was carried out by students who took on one of these printers, students and their lecturers, but they managed to get some very nice architectural details and effects at a very cost efficient price point. But it just illustrates that there is the capacity to get a high level architectural finish at a affordable cost, which is quite an interesting prospect generally to us as architects. This is the project that we are currently working on. It's a social housing scheme in Accrington, which is just north of Manchester. And I'll give you a little overview of that in a second, but just beforehand, I'll just give you a bit more information on how the technology actually works. So we have a short video here. I'll just get it up. And this will give you an idea of just the process. So this is us setting up the equipment at the R&D facility in Drogheda, and this just to indicate, I suppose, what's involved in bringing this equipment to site and setting it up, because it's an on-site production. You can use it in an R&D facility, and there's some people that use it to prefabricate and bring it to site, but from our analysis, it's actually more efficient, and it's probably the best way of working, especially at scale, is to bring the printer to site and then move it around that site, especially in social housing aspect. This took us basically our first time, but we had the support of the Cobot engineers with us, working in a very tight space. Everything from putting the rods to secure it into the ground, to erecting it into a printable format. It took us about a day and a half, all inclusive. They say once a team becomes experienced on an external site, that you can erect it in half a day. We project, when we do our output projections, about a day for assembly and a day for disassembly. This just gives you an idea of how it works. So it's as we say, it's basically a transfer of our Revit models into a digital G code. This is the printer head, and the concrete gets extruded at this printer head. The concrete has about a 1% additive. It has an accelerator that is introduced in the printer head. The accelerator allows us to achieve the high rates of execution. What it does is it brings the strength of the concrete forward. So it allows us to achieve roughly 8 megapascal strength within 12 hours. That's actually stronger than the strength of the block that we're replacing, and it allows us then to implement the other components in a structurally compliant way. This is very simply the batch plant outside, so we introduce local aggregates, that's stone taken from Slane and sand taken from Carlingford, and there are two parts of the ingredients, and then cement is the other part. We just use Irish cement. We're actually using O'Brien's cement at the moment, 42.5 Newton cement. They're based down in Wexford, a great company. And we just fill our silo. This is our pump. So basically the cement in the silo gets mixed with the aggregates in the batch plant. They get churned around. In the batch plant, there is an additive which is called a plasticizer. And what that does, it allows the concrete to be in a fluid enough state that it can be pumped through the pipe to that extruding head. And then when it gets to the extruding head, it gets hit with this accelerator. But these are very small additives. And you can see that's the accelerator where it has been introduced. So this is the concrete being tested. Just do a test to check the viscosity, and we'll do a slump test. Once they measure that, they know it's good to pump. Once it's good to pump, they basically just start the pump, and then the operator would sit next to the gantry and then just oversee that the extrusion is compatible with what is in the program. And then it just runs around in iterative layers. That's running at about 80 mil in width and about 40 mil in height. So that would that'll just continue to run wherever it comes to a window. It stops extruding and then starts extruding. When it comes to, we can integrate this with normal lintels. We manually just place a lintel over an ope, and it'll extrude over it, and then it'll set. So we're just using, it took a bit of time to figure out, but generally we've developed a package where we know how to use this technology with in a manner that's compliant, so we didn't have to reinvent the wheel. So that's just an overview of how the technology works. This is our current focus. It's a project in Accrington. So it's a social housing scheme focused on housing army veterans who have fallen on difficult times but who've got their lives back together. There's 46 units altogether, and there's a community facility. Accrington, just by luck, this project kind of found us, but just by luck, Accrington was an area that was famed for the engineering brick, the Nori brick, which was credited with allowing the large structures for the Industrial Revolution to occur because of its strength. It was the construction technology of its time. It was also specified, such was its renowned strength, as the foundation brick to be used in the Empire State Building. And it just so happens that the first project is happening in Accrington, so we have a bit of the technology is coming back to that same place, which is, we believe, is the next generation of construction. This is just an overview of the scheme. It's going to be a net zero carbon scheme, very socially orientated, common allotments, energy hub to address fuel poverty, a lot of intelligent technology being put in, PV cells and some very other efficient combined heating systems. The overall project, 46 units, and we're going to start with the community centre, and we call it Block 5, which is 6 number apartments. So two bedroom apartments per floor, and that's just an overview of the printer set over the actual foundation slab of the block. This is us running our software. This is called a configurator. Just allows us to see the print path and time it, and it's just another tool. This is the equipment, as you've seen, the gantry, and then the associated batch plant, pump and silo. This is block 5, so 6 apartments, and as I say, we're looking to do this in about 12 days for the superstructure. And because all the other components can be ordered in advance, we're hoping to get the remainder of the roof, windows, doors, floors, and partition walls inside within 18 days total from the beginning of the print. And that's after the foundation, so that's starting from the foundation being complete. These are just some images of the texture and visualizations of the entrance area. This is our community facility, and it's again just demonstrating the free flow capacity of the equipment. You can do a straight wall at the same cost as you can do a curved wall or any type of shape you want to do. And these are just some images. Again, this is kind of just to work as a beacon for the community. It's a very interesting building for humanity are the clients, and it's a great precedent project. And this is kind of the kind of central gathering area for all the tenants in the scheme, and also for the greater community that it's engaging with. I'll just show you, this is just the final video I want to show you quickly. This just gives you a overview of our construction methodology. So foundations, just traditional foundations, go in initially. We're using core deck blocks because we're trying to get a zero carbon accreditation. Once the foundation is in, we erect the printer, call that a day. Then we begin printing. So we start by printing the south block, and we have allocated a day to get up to first floor level, and that just indicates that printing up the first floor level, you drop in your lintels on the oak. That's done manually, just like regular attendances. Then once the south block is printed, day 2, start printing the north block. But whilst that is happening, we're able to have all our prefabricated, pre-ordered components arrive to site and then be fitted, and then we'll alternate between the 2 sides. So again, when the south block, the first floor of the south block has been printed, we'll be putting in the internal partitions and light gauge steel flooring on the north block, and that'll alternate over. We project over 6 days, but we have a contingency for us going outside of that time period. But based on our calculations, that's all very workable, and we hope to achieve it. But if we don't achieve it, it's no problem. It's still a multiple of factors faster than current construction methodologies allow. So we'll continue. This is 3 stories, and that's currently the limit of this printer. You can go higher on another printer called an XL. You can go to currently about 25 meters. So we're up to about just under 9 meters, which is fine for us, 3-story building. Then after the printing is done, the printer goes off site and we get on to the next residential phase. But we can have all these other components delivered, and we'll know that they will fit exactly. And we'd hope to have this completed within 18 working days from our initial start, i.e. after foundations have been completed. That's the end visualization of the final product. So I think that gives you probably a good overview. See, I'm just over 45 minutes now, so any questions? Probably a lot to take in, but very happy to answer them.
Thanks, Justin. It was great to actually finish up with this video to recap everything what you went through. I think, as you said, it's a lot to digest, but I found actually quite impressive. let's take some questions if we have from our audience while they are thinking about that. So I will actually ask a question. So we see actually ambitious numbers like varying from 30% to 70% in terms of like, saving in the labor cost, increased efficiency, increased speed, like using actually less material, reduced logistics, like local material, as well as actually ticking all the boxes in terms of sustainability, even though you need to use cement at this stage, digitalization, modular construction, like having this efficiency. And also I see that it is complying with all the building regulations so far, looking at what we have done in the Europe and the UK. So what are the main obstacles that prevent the industry to uptake these 3D construction printing and replacing with the traditional methods?
At the moment, our view is you can talk about what's happened in Germany, you can talk about what's happened in the US and the level of progress, but until there is a tangible project that has been delivered in the UK or Ireland. So I think it's one and the same. Our view would be that if it's delivered in the UK, it'll be accepted in Ireland and vice versa. So you have to deliver a tangible project. That's why we've been kind of just really focused on preparing for Accrington and basically drilling in preparation for it. And I think our belief on it, once that project is delivered, and then we'll have third parties that will validate and review the actual empirical data, because it's one thing about this about the digital process. All of our data is recorded as we go, and it's a great mine of data, and we'll be able to demonstrate it. But we'll have a university and then also a third party, very well regarded large company who will also validate the data. And I think once that happens, and once industry can see, again, we've been around construction, it's conventional, but once they can see that there is a cost benefit is their main situation, that's what is needed to compel people, because everyone assumes risk, quite rightly, with anything that's new. Nobody wants to be the first. But once that is done, which we hope to execute at Accrington, and we can illustrate that there's a cost advantage here, we believe it'll likely just it'll take off as without having to communicate much more. It'll grow at a rate of knots. We just see a question there about insulation.
Mm-hmm.
Yeah, at the moment James, yeah, at the moment we're just using because of the method of printing, we have to use a loose fill insulation. So at the moment we're using a blown EPS, and we're actually looking at using something that's a bit more ecologically sustainable, because EPS it's very effective, but it has a high embodied carbon associated with it. There are other materials we can use, but we just need to balance the cost for our clients and the ecological benefits. But yeah, at the moment, it's a blown EPS as you would in a standard manner, and that'll happen after the printer is off-site. In Germany, they're using a loose fill, and it's based on a it's kind of it's a rock, it's a perlite, I think. It's a loose fill perlite, which is very effective. But for us, just from a cost perspective, we're using EPS at the moment.
Okay. And there's another question from Niall says, how does the cost stack up with equivalent block work?
Our projections are giving us a 25% cost reduction, and that is based on three factors: the materials, the labour, and then also the cost of the plant being factored into it. However, when we factor in the cost of the plant, it assumes that that printer is being used in an efficient manner, that it's actually working and sweating. So we would make our projections based on about 230 working days and probably an output, I think, just from memory, an output of about 25,000 square meters of wall area per year. And we do that with a contingency of 50%, i.e. that on any given day, we have 4 hours of output. We hope, we try and be conservative in our projections, because there's nothing worse than having it, really high projections and not achieving them, because then it'll lead to people, even though they are good results, if they have in their mind that it's going to achieve X, Y, and Z, and it doesn't achieve it, then you just have disappointment, even though the results are good. So we try and keep it conservative. That's our current projections, but the more we go on, the more reliable that understanding will be. But at the moment, from the get-go, we believe 20 to 25%, but that will increase. We're very confident of that.
Okay.
As we introduce new materials. And also, one other point to make, because we're working within the current building code, we're printing 100 mil wide walls. We only need to print probably 60 mil, so we already have a 40% over extrusion of material, which we could, once everyone gets more comfortable with, which we could reduce down to 60 mil. So that's 40% saving on material on that alone. And these types of things will all increase
Along the way. Okay, thanks. I guess James is writing something. Let's see what he will say. But meantime, I would like to also ask, where do you see actually this technology will have the lasting impact?
Where will it have a lasting impact?
Yes.
I think initially social housing and affordability. I think that's where the demand is. So I think that's the most meaningful impact. But this has been used for renewable technology, and especially the wind turbine. I think that's going to be a big factor as well. I think there's a big, as you can see, energy independence is a big issue, and the west coast of Ireland, I think, is known as potentially the Saudi Arabia of Europe from a wind perspective. So, but we see guys using it. We're over in Copenhagen. We've guys in from New York that are buying these printers to print very large storage facilities, as opposed to using light gauge steel. It's inherently a fire insulator. It's resistant. So
Okay.
it's whichever way you want to do it. We've got some other very nice aspirational projects where we use the free form to help parabolics in a space where acoustics. It's for an interpretive centre for Irish folklore. They're all down the line a little bit, but it's from an architectural perspective, it's very expressive. So there's a lot of directions this goes on, but at the moment it's the utility. I see
Okay.
something else there about cold bridging. That was a big consideration, because you can see a lot of the other guys that apply it. They have a cold bridge around the windows where they continue the print. We have to break the print, so there is no cold bridge, and we've developed details which are compliant. It was through R&D and a good bit of figuring out, but we've developed details that have got over those cold bridge issues.
Okay, for the openings. And I want to ask also again, if we have any more questions left from our audience, you could also step in to ask Justin directly.
Yeah, if anybody's any more questions, very happy to hear. Or you can contact us
We'll share
through,
your details, Justin,
yeah,
then with
through
our
our
members.
business. Yeah.
And then I guess that's it. Like before we close out the session, I want to also ask Justin, if our members, they would like to see your facility in Drogheda and also see the demo of the product and how it's installed, can they make it, or what can we do?
Absolutely. We are working, as we say, we've kept in kind of stealth mode, because we just really need to focus on our work. But we're very happy, and we're very happy to be involved in the construction cluster with like-minded individuals, because it's at such an early stage. The more input and the more intelligent people with experience, it's wide open to be developed. So we're very receptive, and we're very receptive to collaborations, because it's, as I say, it's at an early stage. We print generally from Tuesday, Wednesday, and Thursday on site, And by pre-arrangement, I'll be very happy, or Terry or any of the colleagues are very happy to show people around. We're very proud of the technology, and we've got a really great team. We've got a great engineer, a chap called Marchant. He really knows this technology. We're very lucky to have him in Ireland, possibly one of the most knowledgeable people, I'd say, in the world. And we're very lucky to have that level of knowledge and expertise here. There's also we've had good support from Loudmead Education Training Body, which is it's a semi-state. It's funded by Sulis, and they've actually contracted some open training courses. It's just initial training courses. There's one actually. It was just announced probably yesterday, I think. There's one on the 28th of June, and they are funding it, and it'd be a great opportunity for anybody that is interested. There's limited places, but we can share with you, Mineska.
Yes, please. Then we
There's
can
a
circulate to our members. Yes.
yeah, because I think it'd be a great opportunity to give a great overview, and yeah, so we can share. You can register your interest. We'll send you a link after this, and if somebody is interested. 28's coming up pretty quick.
Brilliant. Yeah. All right. Thank you very much, Justin. Then actually, it's great to see your activities, and I'm sure actually our members are also delighted to see these new technology and how it's applied in different places. Looking forward to see more actually projects in Ireland.
Yeah, so
I
we're
think
working on it. Yeah,
yeah, very good. And yeah, and we could also visit your facilities or finish projects with our members at
absolutely.
some point. We could arrange that, and we will pass your information, contact details to our members if they would like to get in touch with you directly on this one.
Absolutely. Would welcome it. Thanks so much, Vanessa.
Thanks
Thanks for
everyone for joining then. Thanks, Justin. And I
thank
guess
you.
that's the end of our session.